Hi, welcome to our presentation on eco-friendly architecture by Pranjal and Nikki. Today's agenda is that we will go into eco-friendly architecture, discussing what it is and why it matters to us. Then we will discuss the construction industry's impact on climate change by looking at the United Nations Goal 15, which links construction industry directly to the climate change. Next, we will discuss some of the solutions that the architecture industry is already using to reduce our impact on the climate or on our environment. Some of those things are by modifying energy usage, noise pollution, and light pollution, or the use of light. And again, we'll go into the carbon footprint, how we are reducing the carbon footprint through certain practices. After that, we will discuss the advantages of the sustainable production, consumption, and disposal has on human life and the environment. And finally, we will discuss the two examples that we researched, two examples of buildings that are already using these eco-friendly solutions for construction. One of them is Vancouver Convention Center, and the second one is Tidge Observatory. Next, I will let Pranjal take on the next part of our presentation, introducing you to eco-friendly architecture. Now I'll leave you with Pranjal for eco-friendly architecture.
Hi, I'm Pranjal. As I'm going to talk about the eco-friendly architecture or the green construction. Basically, it consists of the four components, that is how we efficiently use the resources or the power, and how to reduce the wastage from the building, like how to reduce the usage of water, and the third one is the minimal environmental impact of the products that we are using, and three of these factors are taken care of in order to provide the good living conditions. Uh, there is an immense need to look at why does it matters. As we all know, promoting human comfort inside built spaces should be one of the main priorities for an architecture or interior designer. So, there is a great need to look at what resources we are using to create that comfort. Are they sources really worthy? As we all know, using renewable source of energy like coal, petroleum, natural gas, nuclear power that do not renew quickly. Even though it has many disadvantages like it leads to the carbon emission, which further changes the climate and leads to the air pollution. Even though it's not finite within our reality, in addition to that, it has lots of impact on public and occupational health problems, even though it becomes more and more scarce due to its high demand. The third thing to look at is the carbon footprint and what gases do actually contribute to the carbon footprint and what human practices led to those emission of the gases. Like burning of fossil fuels, deforestation, wildfire leads to the emission of carbon dioxide. Agriculture, dump site, and sanitary landfills leads to the emission of methane. Agricultural Poor agricultural land management leads to the emission of nitrous oxide. Air conditioning, refrigeration leads to the emission of hydrofluorocarbons. Aluminium production leads to the emission of perfluorocarbons. Electricity and energy equipment leads to the emission of sulfur hexafluoride. So, what's the role of construction on the climate? So, I'm going to talk about the goal 15 as it is about as it is all about the research did by the United Nations Department of Economics and Social Affairs who call for the goal 15, which is about protect, restore and promote sustainable use of terrestrial ecosystem, sustainably manage forest, combat desertification, halt and reverse land degradation, and halt biodiversity loss. As it can be also seen from the picture that how many of the major climatic problems can be solved with the change in the constructional or architectural practices. The building industry has a direct impact on each of these items. So simple measures can be taken to eliminate those climatic problems, like attention to the permeability of the land, how to reduce the carbon footprint of the site that we are building on, choosing building materials for the sustainable production chain. There are many of the solutions that architecture look for to eliminate the climatic problems, like energy optimization, insulation, balancing light. So energy can be optimized by using solar energy with the battery and by getting the energy from within the soil and by reusing the energy from the HVAC or the sewage. Like energy is used to from the wastewater to heat up the clean water. Like the goal is not to waste the energy but to reuse it. And the second thing to look at is the insulation, noise or the energy conservation insulation. Like what materials to choose for creating that insulation, like the decisions for choosing masonry over concrete and adobe brick over both, which has less impact on environment. And the third thing to look at is the balancing light. So for understanding the purpose of choosing a glazed walls, we must need to look at the two factors, that is the solar factor and the visible light transmission, as choosing the material of the light can be used to block the light to keep a surface cool and allow light to create a surface warm. So decisions based on that will lead many solutions for the problems of climatic change. To be continued with the solutions for the climate change, there are 5 ways that can be discussed that I will discuss which lessen the carbon footprint. As first of all is passive house criteria. As passive house criteria is building a model which generates its own energy. Like as I also told earlier, using the natural resources for creating the energy or by reusing the energy. So for meeting the criteria to be a passive home, there are so many criteria that we must meet of, that are like air tightness, proper envelope for the building climate, minimization of the systems, and many more. And the second one is biophilic design, as like use of natural shapes to create a building and to reconnect human beings with their environment. As it can be clearly seen from the picture of the biophilic design, that the hanging gardens of Babylon are probably one of the oldest records of biophilic design being applied to the architecture. And the third one is the green roof, as we all know, by introducing greenery on the roofs, by introducing shrubs or the native plants on the roof, that not only reconnects human being to their environment but also eliminates many of the problems. It improves the air quality, provides the creative leisure area, and helps in very good rainwater management. The fourth one to look at is the xeriscaping. It's really interesting to look at it. Like xeriscaping is the landscaping that reduce or even eliminate the need for water irrigation. Although it is a strategy generally used in the regions where there are not many water resources. There are many advantages of having xeriscaping landscaping, like reduction in water consumption, less probability of erosion, occurrence in several areas, and the third, like it eliminates the need for using harmful pesticides and herbicides. The last one is ecological bricks, like using soil cement blocks for the construction purpose. Not only using the ecological bricks, but also to look at its manufacturing process, like using compression instead of burning, which not emits polluting gases into the environment. And even though it really provides a good thermal and acoustic comfort. And we can also look at about the design of the ecological brick so that it eliminates the need for the joints that we use to join the blocks. Advantages of sustainable production, consumption, and disposal. The first one is the resilient and adaptive infrastructure, as it can be clearly seen from the picture on the right about how sustainable buildings impact on industry, innovation, and infrastructure, like a good waste management, proper infrastructure, and the proper house planning and development, and the usage of renewable energy leads to the buildings with a zero emission. And the second one is the economic growth. As we all know, the whole recyclable process itself creates a lot of job opportunities from the traditional economy to the sustainable economy. The third one is the affordable and clean energy. As the renewable source of energy is less scarcity and more affordable, and even it leads to less carbon emission. So obviously it's create the less carbon footprint. And the fourth one is health and well-being. As using all of these sustainable practices leads to clean air, water, and food, which in return create a healthy lifestyle. The last one is taking responsibility. As consumers, the government, and manufacturers can take the responsibility of implementing the sustainable building and introducing the sustainable production, consumption, and disposal. And that's all about it. And further, Nikki will explain you the two advantages that we have researched on.
Okay, thanks, Pranjal. So our first example is the Vancouver Convention Center, which is located in Vancouver, BC. It is 1.2 million square foot of a building structure. Well, it has 14 acres of land. 14 acres of it is on land and 8 acres is over water. So with 1 million square foot of convention space, 90,000 square foot of it is used for retail space, 450 parking stalls, 400,000 square feet of walkways, bikeways, and public open access. The purpose of this building was to create a public and to create space to hold public and private events. The Convention Center program emphasizes spaces for both public and private events, mixing the energy of convention visitors with the social life of the city. The stated goal for this project, for the building, was to bring urban ecology into the downtown core, and upon its completion in 2009, the City of Vancouver passed an initiative to become the greenest city in the world by 2020, releasing a 10-part action plan addressing carbon, waste, and ecosystems. Keeping that in mind, we moved the convention center incorporate a lot more of the eco-friendly practices into the design, which we'll discuss next. So the coolest part of this building is the green roof that's it hosts. So this is the largest non-industrial living roof in North America, featuring 400,000 indigenous plants and grasses, which is great because since they're indigenous, they require least amount of care because they are part of this area. They are able to survive this land, the climate here. The second part of this building that's also very interesting is the visible light transmission and biophilic design that's been incorporated into the building. 90% of the above grade building is enclosed in ultra clear glass curtain walls, and even the building perimeter enclosure is in ultra clear glass systems. This allows the users of the building to remain connected to the exterior of this building. So when you're inside, you can still remain connected to the views of where you're really at, the mountains, the water, and the commercial aspect of this area. At the same time, what it's doing is allowing a lot more of the natural light into the building, and in Vancouver we don't get that much sun, so this is great to be able to use some of the light, the natural light, and it reduces the need for artificial light in the building. And this design took about 3 years to come to fruition. The materials used in this building are great because the intention was to select materials that maximize recycled content, recyclability, durability, renewable material use, and local harvest and extraction. So 16% of the recycled content is recycled content, 21% regional content, so it was local, and 86% of the construction was diverted from landfills. So that's really a cradle-to-cradle design again. The next part of our report discusses the Tidge Observatory. So that's our second example that we observed or studied is the Tidge Observatory. This is a bird observatory located in the Netherlands. This is also another eco-friendly architecture built in 2019. It was designed by Rowe Architects and R-O-N-D Architecten. Tidge is a Dutch word that means tide, but this building actually looks like an egg. It was designed specifically to look like an egg. This is a 150 meters squared egg. The location of this egg, it's nestled in an area of natural reserve in the Netherlands. It's surrounded mostly by water, and mostly it's occupied by birds such as spoonbills, sand martins, and common sandwich terns. The intention of the architects was to design a building that has the least impact on these birds, while people could come in and observe the birds in their most natural way, without any disturbance. This was achieved through the use of right materials, shape, and math. The weather in Netherlands was one of the things that they had to keep in mind, was that the materials must be able to withstand rainfall, because Netherlands gets 79 centimeters of precipitation each year. This is also, since it's located in a natural reserve near Herringvillet sluices, this structure is partly submerged in water a few times a year. So sluices are gates that hold back water, and these sluices have been recently opened to improve water quality and biodiversity and to stimulate fish migration. So when these waters are released, or a few times a year, the water floods the lower part of this egg. So the architects, the designers, used biophilic design because they used the stern egg as the shape for inspiration. They also made sure that the path to and from the egg, so from connecting from the parking lot to the egg, is a tunnel. So it's underground, it's covered by sand, and the sand is used by the birds to create their for their eggs. So the visitors are completely hidden from the birds. So it has the zero visual footprint because the structure is completely camouflaged within its environment. The design of this structure was created through parametric modeling. This is an AutoCAD-based modeling software that uses mathematical equations to create the design. So by just changing one little variable, you can change the entire design of the structure, but all the structure, the mathematical equation takes into account a good ratio between the form, structural integrity, size of the timber, and size of the openings. And the great thing about this is that the structure could be created in small little 402 small wooden parts, to be exact, and they were made in the factory, constructed in the factory, and then brought over into the site to be assembled. So the least amount of impact on the environment during construction. And this structure was created in a way that it can be dismantled at the end of its life. So it's a temporary structure with the least amount of destruction on the pieces that were used. So the material can be reused easily for the next project. As I said, the floor of this structure is covered or flooded by water many times a year. So the materials that were used for this project are very interesting. The bottom part of the egg is made with akoya wood. And this wood the cellular structure of this wood is re-engineered. It's been changed to block moisture, and so it's really great for this project. It's non-resistant, it's rot resistant, sorry, and it's recyclable and durable. This is the material that was used for up until the highest possible waterline point on the egg. Next part of the egg, which is the top shell, is made of pine wood, and this was used because it's sustainable. It's easy to replenish in the forest because pine wood grows back quickly. So least impact on the forest and the environment in the forest. The floor of the egg was made of concrete and CLT. CLT is cross-laminated timber. It is used for its strength, which is because it's a number of crosswise glued slats placed at right angles to each other. And this creates stability, and the concrete creates stability for the structure. This entire structure is cradle to cradle because even the tunnel that's underground tunnel for access to the egg has been created by mooring posts and azobe planks, which were recycled from a brick industry. So it's taking into account where these materials are coming from. So this makes the Tidge Observatory truly a cradle-to-cradle design in every sense. The conclusion of our project is that the conclusion we came up with, our report concludes that if there is a solution to the problem our ecosystem faces today, then it is in design. Nothing has a bigger footprint on our ecosystem than our infrastructure. Nothing impacts infrastructure more than the architectural design. So the solution is in design because the problem is in design. We have designed buildings in the past that have not taken the environment into consideration. Once we begin designing buildings with the environment in mind, we will resolve most of this problem, and we'll have a great impact on the ecosystem problem. And that's all for now. Thank you for watching our presentation. This is me, Nikki, Navjeet Raglutra, and Pranjal.
Thanks for watching. Bye bye.
Bye.